Relativity, it was from Einstein. He said that if we have the mass somewhere, if we have a space around this, like that, this space is not planar. This, the weight causes that it's we have because that we have a field around it. So it means that if it's not like that I have the Earth here simply, and this one the space is linear like that. When we have a space due to the mass of the Earth, the space will be curved like that. Curved. So this curvature, which appears in it, is called Schwarzschild field. I don't know if I write it right. Schwarzschild field. And this Schwarzschild field is not only for the Earth. Anything in the space that has a mass, it will create this field around it. So, for example, if I look here, if I have the Earth here, and I have, Sun here, and I have the Earth here, and I have a satellite, but satellite is too small. Then the Earth is inside this field itself due to the mass of the Sun, the gravity of the Sun, and the Earth and the satellite is inside the field of the Earth. So this causes that if we have a force, we always think that the forces are propagated along a line. But when we come to this space, the curves will around the curves, and also between Sun and Earth will be curved, not the line. That's the space-time principle that Einstein presented, and he said that the gravity can create a field, non-linear field around it. Yeah, it doesn't let that the forces are propagated linearly. So why is this important? When we want to solve this Kepler equation or the acceleration, we consider that the forces are acting at the satellite linearly, like this line. But due to the mass of the Earth and the gravitational field of the Earth, it doesn't let that these forces are acting like this. They will be like a curve. This is not only that, and also there are some, because of the rotation of the Earth, also we have some relativity based on the Earth's rotation. So it's complicated, but I have read an article which says that they are not very important and not significant, I would say, in gravity field modeling. But maybe for orbit determination, if you want to come to very high precision in the near future, they will influence. So if you want to see how can we compute this effect, let me share another document with you. Again, I refer to this IRS, and if you go down, you will find this part, space-time coordinates and equations. So it's a little bit complicated, but I want to show only one thing here, this formula. That is interesting. It says that you have the mass of the Earth. Let me open the pointer. That's my pointer. This is the mass of the Earth. It's the gravitational constant. This is the absolute value of the geocentric distance of the satellite. And beta and gamma are two constants, which are 1 for general relativity. R dot is the velocity of the satellite, or the velocity vector, and this dot is the dot product or the inner product. And here is the position vector of satellite, and x again is the velocity, and the inner product of the position and the velocity is with the angular momentum of satellite. And this will be cross product, and this is mass of the sun. So this relativity is relativity, or this effect, the acceleration of the satellite based on the mass of the Earth and mass of the sun, because the Earth is inside the Schwarzschild field of the sun, and the satellite itself is inside the field of the Earth. So then you can compute the satellite acceleration due to general relativity simply by this formula. So two factors which are important here, or these are all defined here. R is the position of the Earth with respect to the sun. And if you come back here, you will see that you need, let me annotate, you need the speed of the rotation of the Earth, the speed of the Earth with respect to the sun. So you need that speed, and also J is the Earth angular momentum per unit mass, and we have this value for that. So you see that computing this effect for orbit to the satellite acceleration is not hard. You can compute it for if you have the satellite position and velocity. And again, I am telling you that the last term here, I suspect that it should be small. Its effect is related to the general relativity between the Earth and the sun.